Have you seen this video floating around? It's incredible. You've got a diver deep in the open ocean who gets this unbelievably close encounter with a sperm whale. The whale comes right up, turns, and then just unleashes this series of intense rhythmic clicks. It is absolutely stunning, and let's be honest, it's also a little bit unnerving. So in today's explainer, we're going to dive deep into the incredible power that's hiding behind that sound. And you can totally see why, right? That's a quote from someone who saw the video online, and it just perfectly captures that feeling. I mean, you're watching this massive, intelligent creature basically running a full diagnostic on a tiny human. But what's really going on here? Is the whale just saying, hello? Well, not exactly. What you're actually hearing is a form of biological sonar. Those clicks, that's echolocation. The whale is blasting out these powerful sound waves and then reading the echoes that bounce back to build this incredibly detailed 3D picture of the diver. Somebody online called it an acoustic pat-down, and that is the perfect way to describe it. It's just a powerful reminder that this is how the largest toothed predator on Earth sees in the pitch-black darkness of the deep ocean. Now, for the most part, sperm whales are pretty docile and curious when it comes to humans. But what you have to understand is that they possess this almost unbelievable hidden power. It's not their size and it's not their teeth that make them so formidable. It's the fact that they are, by a huge margin, the loudest animals on the entire planet. Okay, so just how loud are we talking about here? To really get it, we've got to look at the physics of loudness, and I'm telling you, the numbers are genuinely mind-boggling. So scientists have actually measured a sperm whale's click at up to 230 decibels underwater. Now, I know that number, 230 dBs, probably doesn't mean a whole lot on its own. It really needs some context, because 230 decibels isn't just loud. It's powerful on a scale that is really, really hard to comprehend. All right, to get our heads around this, let's put it on a scale. A normal conversation is about 60 decibels. A loud rock concert, that's around 120. A jet engine, from about 100 feet away, is 140 decibels. Now, here's the tricky part. You can't directly compare decibels in water and air. But if you do the math to convert it, a whale's click is the equivalent of about 174 decibels in the air. That is way, way louder than a jet engine at close range. And here's where it just gets completely wild. The decibel scale is logarithmic. It's not linear. So what does that mean? It means the power increases exponentially. Going from, say, 120 decibels to 130 isn't just a little step up. It is 10 times more powerful. So when you actually do the math, that 230 decibel click from the whale has an acoustic energy that is literally billions of times greater than a rock concert. In fact, sound can only get so loud in our atmosphere before it basically stops being sound at all. At sea level, that physical limit is 194 decibels. You go past that point, and the vibrations are so intense that they create a vacuum between them. The sound actually becomes a shockwave, a moving wall of high-pressure air. A sperm whale's click is powerful enough to do way more than just burst your eardrums. In theory, it can vibrate a living creature to death. A sound that powerful is, well, it's hard to top. But it does make you wonder, is a sperm whale the absolute loudest thing on Earth? Or has our planet ever cooked up something even louder? Well, as incredibly powerful as that sperm whale is, the answer is no. And you know what? It's not even close. In all of recorded history, there was one sound so loud it makes the whale's click seem quiet. A sound that literally circled the entire planet. Back on August 27, 1883, the volcano on the island of Krakatoa erupted. The sound it made was heard clearly on islands 3,000 miles away. I mean, that's like an explosion happening in New York and people hearing it clearly in Dublin. People that far away said it sounded like a cannon going off. The atmospheric pressure wave it created was so huge that barometers all over the world tracked it circling the Earth 4 full times. The estimated decibel level right at the source of the Krakatoa eruption was 310 decibels. That number is so far beyond the 194 decibel shockwave limit that it's almost meaningless. For anyone who was nearby, it wouldn't have even registered as a sound. It would have just been an instantaneous, completely unsurvivable blast wave. So here's the crucial point. Sound isn't just something we hear, right? It's a physical force, a force that can create shockwaves and exert real physical pressure on a body. And, well, once humanity understood that power, it was only a matter of time before we tried to turn it into a tool and a weapon.
This right here is probably the most famous example. It's the Long Range Acoustic Device, or LRAD. It was developed by the U.S. military after the attack on the USS Cole back in 2000. The idea was to have a way to send really clear, loud warnings to other boats from a safe distance. But it also has another function. It can emit this piercing, incredibly painful tone that's designed to disorient people and make them go away.
But it's also really important to keep things in perspective here. While, science fiction absolutely loves the idea of a death ray made out of pure sound, the reality is a lot more complicated. A 2018 research paper on weapons control actually concluded that the practical challenges of projecting that kind of lethal energy are just immense. The LRAD isn't the only one, of course. You've got things like flashbang grenades, which use a deafening 180 decibel blast to stun and disorient people. Other devices have been developed for riot control. And then you get into these controversial commercial devices, like something called the Mosquito, which blasts a high-frequency noise that is intensely annoying to teenagers but completely inaudible to most adults. So, as you can imagine, this technology brings up some very, very complicated questions. When does a really powerful loudspeaker cross the line and actually become a weapon? How are we supposed to classify these devices? And what are the rules for using them? And this slide really gets to the heart of the debate. On one side, you have manufacturers and military proponents who classify the LRAD as an acoustic hailing device, basically a tool for communication. They argue it's a non-lethal option that falls within the laws of war. But on the other side, you have critics and even some NATO reports that define it as a weapon, plain and simple, because it is designed to use acoustic energy to cause physical effects like pain. And the concerns that critics bring up are pretty significant. Beyond the obvious risk of permanent hearing loss, there's a problem of control. In a city, for example, sound bounces off buildings, which can make its effects unpredictable and indiscriminate. And there's a wider concern, too. These are tools that were developed for naval warfare that are now being used on domestic city streets, and that blurs a very important line. So this is where our whole journey ends up. We started with the incredible, intricate sonar of a sperm whale, and we ended with the focused, powerful beam of a sonic device. We've seen that sound is this immense power, a force that can be used to see, to communicate, and yes, to control. So the fundamental question we're all left with is this. As our technology keeps getting louder, who gets to decide what we hear?